Today on MLPro, we're going to learn how to do text classification using deep neural networks in Tensorflow/Keras. So on this open-ended problem on MLPro.io, we see that our goal is to build a classifier which can predict which discussion forum category a particular post belongs to. So as input, in our XTrain tab, we see that each data point looks like what I've selected here. So if we inspect it, we see there's a from line, a subject line, and then some text. We also notice there's some /n characters. Those represent new lines. And so that's the data we have. That's one data point. We see the next data point looks similar. So in general, that's the type of data we have. And what we're trying to predict from each data point is which discussion forum category that text belongs to. So it could be on a discussion forum about graphics or about Mac hardware or Windows or for sale things or motorcycles or hockey, etc. So that's the goal. And these categories, of which there are 20, are represented by one-hot encoded labels, which we see in the YTrain tab. So one-hot encoded representation is a 1 in the position for the class of the true label and 0 everywhere else. So that is the data that we have to work with. We see in the coding editor that we have two functions that we have to fill out. The first one is called ModifyX. The whole point of that function is to take the text that we have and turn it into numbers, because as we all know, in machine learning, you can't do math on text. Machine learning relies on numbers. So you can't have f of from whatever this email, subject, what car is this? Like, you can't imagine a mathematical function that would take this type of string as input. It's kind of odd to do math on that. So therefore we need to convert the text into numbers so that we can do math, and in particular machine learning type of math on it. And there's many techniques to do it. So here we have a TF-IDF vectorizer, which is a popular feature representation for words. And that's the default that comes in this problem. We're not going to change it for this video, although I highly recommend that you look into alternative ways to represent the text in this problem, because I guarantee you that other methods will result in much better performance. So that's on you. I'll also, actually I won't say any more than that, because we will have a future video that goes in depth about ways that we can modify this ModifyX function to improve performance on this problem and in general in text problems. But today we're going to focus on the create model function, where we return a TensorFlow Keras model that will take the data that's this data transformed in this way, and then attempts to predict the labels represented as one-hot encoded labels. And the default code that comes in this problem is a shallow neural network where the first hidden node layer has 2 nodes in it with ReLU activation, and then the final layer, the output layer, contains 20 nodes. By default, because I was changing this around earlier, by default it comes with 10 nodes, but if we run it as it comes by default, and I'm going to move my screen over here as it's running for the first time so that we're not blocking the console output, well, we see that we get a value error. And in particular, we see value error shapes none, 20 and none, 10 are incompatible. That's because by default, this boilerplate code has 10 output nodes, but we are given in the problem that it's a 20 class problem. So we got to go ahead and change that to 20. Let's make sure that everything else all the other parameters make sense before we hit run again. So softmax activation on the final layer, that makes sense because in multi-class classification you want to usually use softmax activation. We use categorical cross-entropy loss, which is a common loss function for multi-class problems, auto-optimization, fine choice, and oops, and so and a learning rate of 0.1. So let's hit run now that we've, oh wait, I didn't change the number of classes to 20. So let me change it back into 20 and hit run again. And let's just start off by verifying that this boilerplate code works. And then we'll go from there. So this is a deep neural net, so it takes some time. And we see, okay, the output, the test accuracy was about 12%. The test precision is 0, and the test recall is 0. So that's not too good. One thing we can do is just add more nodes to our neural network. So let's add more nodes to the hidden layer, hit run again, and see what happens. And as that's running, let's play around with adding another hidden layer into the network and see how that does. So in TensorFlow, when you add a second hidden layer, you don't need to specify the input shape again. It's automatically calculated. You only need to specify the input shape in the first layer. So we remove that in the second hidden layer. And okay, the accuracy is still at 12%, but now we're getting non-zero values for precision and recall. That is an improvement. I should also point out that there's 20 classes in this problem. So if the classifier was guessing at random, we would get 5% for accuracy, precision, recall. So anything higher than 5% is better than random. So just pointing that out. Okay, so I added this new hidden layer. I'm going to hit run again, and we're going to see what happens now. And as it's running, let me also point out that 0.1 is a particularly high learning rate. Okay, so accuracy, precision, recall went low again. So let's just take away that hidden layer, and let's change the learning rate to 0.01 and see what happens. So learning rate is a very important hyperparameter. It's arguably the most important hyperparameter because it determines how fine-grained your neural network should search its parameter space. We can talk more about what that means later. But notice, just by changing the learning rate, not changing anything about the neural network architecture, but just changing the learning rate, accuracy shoots up to 47%. That is almost 10 times better than random. Precision goes to 100%. Recall is still at about 8%. Okay, let's try 0.001. See what happens. And so it is running, but I can't emphasize enough how important learning rate is as a hyperparameter. You should always try out different learning rates. Unfortunately, there's no scientific way to search the hyperparameter space other than guess and check. The reason is because there's no scientific way to do it without doing the entire backpropagation process yourself, but at that point you might as well just try a different learning rate and try a different value. And therefore, we just have to guess and check. Okay, so let's try 0.005 and see what happens. But you get the idea. Now that we're trying smaller learning rates, we can actually experiment with adding in more layers back into the neural network. Okay, notice this okay performance again. And let's try ReLU activation. Well, let's not try, we have to use some nonlinearity there. And let's hit run again. So I'm actually going to end on that note. A dense neural network is probably a great choice for this problem, but the key message of this video is, in addition to learning how to do these open-ended problems on MLPro, emphasizing the importance of the learning rate hyperparameter. So you can play around with these choices. You can play around with adding a dropout layer. I guess I can play around with that here. Dropout adds some regularization to the neural network. Probably a good idea because the data set in this problem is relatively small. So that's a good choice to make often. And yeah, we could be good. We could play around with the dropout rate, play around with more layers, different numbers of nodes per layer, different nonlinear activation functions, and different learning rates. So we can get reasonably good performance considering this is 20-way classification. If we really want good performance though, we're going to have to explore this ModifyX function. So if you want extremely good performance, you're going to have to use some representation besides a TF-IDF vectorizer. And that is beyond the scope of this video, so stay tuned and we will talk about that in the future. Thanks for watching. Hope this was helpful. Bye.